Good morning to everyone. My name is Piotr Kałuża, and I'm a solution architect at Sycope, and I'm happy to have a chance to show you our product and to answer the question how to monitor and protect your network and the network communication. So let's start with the presentation. How to monitor the network. We've got a few approaches to monitor the network traffic, network devices. The first approach is to network the network devices. So we can tell what is the device saturation, what is the interface saturation, but we know nothing about the reason of this saturation. We don't know who communicated with whom, how many data they exchanged, what was the real reason of this saturation. So in the network device monitoring, we can use a few different protocols like SNMP, WMI, SSH to just check the status of the network device and show this information. But to monitor the network traffic, so find the information, who was the source of the communication, who was the destination, what protocol or application they used in the network communication, we need to choose flow protocols to analyze the net flow data, or packet sniffing to record, capture the packets, analyze the packets, analyze the payloads of the packet, and tell something more about the network communication. I will show you what is the difference between those two approaches in one of the next slide, but for now keep in mind that we've got two different approaches, and Sycope is using the first one, I mean the net flow data protocols and net flow data analyzes to analyze the network traffic. So what is Sycope? Sycope is a solution for long-term data storage from multiple net flow data sources, from many different net flow or flow protocols exporters. We can collect this data, store this data, and use this data for analysis, for network traffic analysis and for security analysis to detect unwanted or suspicious communication in the network. We can detect both unwanted and suspicious, because suspicious communication is something connected with network attack. Unwanted communication is something what is connected with misconfiguration of the device. So it's important to separate those two security reasons of data analysis. At the end of the analysis, we can visualize the data to show very nice charts, tables, to show in details what was the network traffic in the past. We can create the report, and of course, because this is the net flow data analysis, it's possible to use it for a network of any size. So you can use a Sycope in a very small network and extremely large network, because both cases can be covered by Sycope. what are the key benefits of the Sycope? So the first thing is reducing cost of network observability. You've got everything in a single place, in a single solution. So no matter how many devices you want to monitor, from how many locations, you've got everything in one place. This is also vendorless monitoring. So you can use flow data to monitor devices from many different vendors. Mainly, the NetFlow protocol is used by Cisco, but different vendors created their own compatible protocols to monitor the data. So Juniper created JFlow, Huawei created NetStream, and we've got open protocol called IPFix with similar features, with similar ways to analyze it. So many different vendors, many different devices can create flow data, and we can save this data and use it for the analysis. The quick implementation of the product. So Sycope is available as a virtual machine. So after the deployment, it's necessary to assign IP address, make some basic configuration in the system, and send the data to the Sycope collector. And after a few minutes, you will see the first result of the data analysis. So it's not complicated. Many different elements in the system are pre-configured, so it's easy to use, and you will see the first result after a few minutes. And the rest of the configuration is the customization of the product. And of course, you've got everything to make the troubleshooting of the network. So if anyone tell them this is the problem with the network, you've got the hard evidence to tell is the problem with the network and in which place of the network the problem occurs. So okay, use cases. For today, I prepared a few use cases to share with you to show the value of the product. I prepared a few for all of our modules, but before I will share with you the use cases, I would like to tell you about the Sycope architecture. So we've got a virtual machine called collector to store the data from many different flow data exporters. All devices can send the net flow data. So you can send the flow data from switches, from routers, from firewalls. You can use these devices to send a report about the network communication which went through these devices. But in some cases, you don't want to use the native implementation of flow data in the device. So in these cases, you can use Sycope Probe. Sycope Probe is a dedicated machine to transform the copy of the network communication into the net flow data. So it's necessary to send the copy of the packets through span port or mirror port or through device like tab or packet broker to the probe, and then probe will transform this copy of the communication into the net flow data and will send the data to the collector. In some cases, it's very useful to use probe, because probe can create the pure net flow, but also can enhance the net flow with extra data. So probe can measure the performance of the network, because probe see every single packet of the communication, so can measure delays, retransmissions in the network communication, and can send this data to the collector. Probe can also analyze the payload of the packets. So it's possible to enhance the net flow with the extra information from layer 7, and I will tell you a little bit more about this function in the next few slides. Okay, but what is inside the the collector? We've got 3 modules to analyze the data. The first and the basic one is visibility, to show the information about the network traffic. So using the visibility module, it's possible to tell what was the source, what was the destination of the communication, how much data they exchange, through which protocol, through which application, what was the time of the connection, and few other things about the network communication. So basic monitoring you can achieve with the visibility module. But if you need a little bit more, so if you need to measure the performance of the network, it's necessary to use the performance module. The performance module use probe to measure the delays between the packets, to measure the retransmissions in the network, and can analyze this information and show the statistics for the network performance. And the third module is security, to detect unwanted or suspicious communication in the network. And as I said, we can detect suspicious communication. So communication with suspicious host from the reputation list with bad reputation, or some suspicious behavior of the host in the network. So we can detect something like network scan, dictionary attack, and a few other suspicious behavior in the network. But we can also detect wrong configuration of the host in the internet. So, for example, communication with unknown DNS server is not a suspicious communication. It's something what is unusual, what is probably unwanted, and if we detect this communication inside the network, we can tell that, okay, probably this host has a wrong configuration. Maybe the DNS server on the host is configured in the wrong way, or something else had happened because of that. So we can detect both unwanted and suspicious communication in the network. Okay, so let's talk about the use cases, and let's try to answer the questions how to use Sycope to analyze the network traffic and the network performance. The first use case is compliance. So I'm pretty sure that your government or your security police in the company enforce you to keep the information about the network communication for some time. Sometimes it's keeping the log for a few days, few weeks, but sometimes it's about keeping the data for few months or even longer. So how you can meet these requirements from your government or from security police in your company? As I said, we've got two approaches to analyze the network communication. So we've got NetFlow approach and full packet capture. In case that you are using the NetFlow data, it's possible to reduce the original data to the metadata in the proportion 500 to 1. So you will keep 500 times less data than the original data transferred in your network. So if you would like to capture 10 gigabits of the traffic in your network for 1 minute, it's necessary to provide 75 gigabits of the storage per every minute. So it means that to capture the 10 gigabits of the traffic for 1 day, you have to provide over 100 terabytes of the storage for this recording. And try to imagine that you have to keep this recording for 3 months. It's almost impossible to keep so much data in the about the network communication. I don't want to say that this approach has no pros, because we've got full data for diagnostic and forensic analysis. We see everything, so it's easy to analyze this data. But we can also see some troubles with this. We've got too many details. We see everything, so it's useless from this point of view, because we see too much. Also, a lot of data right now is encrypted. I think that around 80% of the network communication is encrypted. So you've got a full recording of the encrypted traffic, which is totally useless for you. And the architecture is very, very complicated, because it's necessary to install many probes, many recorders to capture the traffic in the network. To do the same for 10 gigabits of the communication using flow data, you have to provide 150 megabytes of the data per every minute. So it means that you have to provide over 200 gigabytes per day. It's still a lot, but it looks much, much better than recording of everything. Still, you've got a full visibility in this communication. It's compatible with many devices from many vendors, so it's not necessary to install any additional solution in your network, and you can use this data for network and security monitoring. As I said, it's still a lot of data, so we decided to create 3 features to help you store even more data on the same storage, or extend the storage to keep more data. The first feature is stitch flow. It's a feature to connect the 2 flows into the single connection log. When the exporter creates the flow data, exporter creates two flows per single connection. One flow is to show the communication from the client to the server, and the second flow is to show the communication from the server to the client in the opposite side. So few fields in both flows are the same. So we can just stitch those two flows into a single line to save some data, to save some storage, to keep this information in the system. So the first feature, stitch flows, give us a chance to store more data on this same storage and help us to analyze the network traffic, because we see both sides of the communication in a single row in database, so it's easier to analyze. It looks like the connection log. The second feature is data deduplication. In the network, we usually see the same communication which goes through many different devices. So communication from the client in the branch office and the server in the main office means that the packets go through few devices in the network. It can be a switch in the branch office, the main router in the branch office, the main router in the main office, and some switch in the main office. So we see the same communication for few times, and we receive the two flows from every single device. So we decided to stitch the flows from every single device and deduplicate the data. So to show that we see some communication from computer to the server, and we see that this communication went through this and that device, and we are going to report this information in our system. So the duplication doesn't mean that we are cutting the data and reduce the visibility of the network. It means that we can show the path of the traffic in the network. We can tell through which devices, through which interfaces the communication went through, and help you analyze the data. And the third feature, maybe it's not the feature itself, but it's our licensing model. In our licensing model, we are using only a single parameter to create the proper license. It's number of flows per second received by the collector. So if you need to keep the data for a longer period of time, you have to assign a bigger storage to the VM, and it's possible to keep it in the system. So it's easy to analyze the data even for a very, very long time. Okay, the second use case is about the solving performance issues. Imagine that we've got an application in the network, and someone is trying to use this application and see the icon like this. So data is loading. So we are waiting, and after a few seconds or a few minutes, the user is going to be angry because it's not possible to work smoothly in the application. The user is waiting for some period of time after every single click. So his decision is to call to the application admin and ask about the help. So what is the typical answer of the application admin? Strange. It looks that everything works fine. It's not my problem. Try to ask someone else. Maybe this is the problem with the network. So what is the typical answer of the network administrator? Network works fine. I do not see any problems with connections. Network is stable. Ask someone else. Maybe ask the server administrator. So at the end, the user is angry because no one can help the user and the problem is unsolved. What we can do in this case? We can measure few parameters of the performance to tell where is the problem. We can measure the server network time to measure the server delay. We can measure the client network time to measure the client delay, because maybe this is a problem with the client computer, not with the application or with the server. We can measure the initial server response time to tell, is it the problem with hardware or with the application? Because with initial server response time, we can measure the time, the response time of the application. And of course, we can measure the retransmissions to tell, is it the problem with maybe broken cable or broken interface of one of the device. How we can measure the performance metrics. As I said, we are measuring the delays between the packets during the communication. So we can measure the delays, visualize this information in the system, and we can give you a chance to find the real reason of the delay in the network communication. To measure this delays or these retransmissions, it's necessary to use the probe, because probe as a dedicated solution can measure the delays between the packets, can measure the retransmissions, and can send this information as enhanced flow to the collector. We've got two ways to plug the probe to the network. The first one is by using the span or mirror port on the network device. The second one is to use the tap or packet broker device to send the copy of the traffic between host A and host B to the probe, and then probe will transform this copy of the communication into the netflow data and will send it to the Sycope collector. But using a probe can give us also extra information about the network traffic, because probe see the whole communication, can see the packet, but not only the header of the packet, but can also analyze the payload of the packet. It means that probe can analyze the payload and reveal the real application. For example, when we see the HTTPS communication, it's hard to say what kind of the data is encrypted. But we don't have to decrypt the whole data to reveal the real application. So the typical flow exporter can show us that this is the HTTPS communication, but probe can analyze the payload and tell that, okay, it looks like HTTPS communication, but indeed it is YouTube or Facebook or Teams or WebEx or something else. So probe can analyze the network communication and detect over 250 different layer 7 applications to tell what is the real application in this communication. So probe can analyze the payload of the communication and show us the real application. Okay, this was the one of the enhancement in the NetFlow data. So real application ID was the one of the real enhancement of the data. But probe can also analyze few different protocols, the extra layers of the data. So using the probe, you can also analyze the DNS communication to show the DNS query, the DNS response, the type of the DNS record, and few other things in the DNS communication. Probe can also analyze HTTP communication to show the communication for HTTP application, and can analyze the JA3 hash to categorize the communication and find the suspicious communication. Because, for example, every single virus creates his own JA3 hash. So if we can also calculate the JA3 hash and compare it with the suspicious JA3 hashes, it's easy to find the suspicious communication in the network. So this is the enhancement from the probe side. But also many different devices can enhance the flow data with their extra fields. So, for example, firewall can add extra information to the NetFlow data about the number of firewall rules for this communication. Was it allow or block, and few other things like IPS analysis, antivirus analysis, etc., etc. So different devices can add extra fields to the NetFlow data, and our collector is able to discover these extra fields in the NetFlow data and can add it to the database. So we created something what is called discovery mode to discover the extra fields, extra information inside the flow data and extend our database to save this information and to use this information in the traffic analysis. But right now, let's talk about the security model to show the real value of security analysis. This is the multi-layer security model. So probably all of you know this multi-layer security model. We've got perimeter security here. So perimeter security means that we are using firewalls, next-gen firewalls, UTMs in our network. So we've got a device like this at the edge of the network, and we can analyze the communication from the network to the internet or from the internet to the network and detect some kind of unwanted communication. But as I said, we usually see only the information from the internal and to the external network, or we can see the communication between the segments in the network, but we do not see the communication inside the network segment. So we've got some lack of visibility in here. We've got also the endpoint layer. Endpoint means we are using antivirus software or some security solution to protect the endpoints in the network. But it's not possible to install antivirus software on any single device in our network, because it's not possible to install antivirus software on printer device or on the IP phone. So we've got a group of devices with operating system connected to the network, which we cannot protect by antivirus software or by endpoint security solution. So this layer also will not cover the full protection of the network. The third layer is network communication analysis. Here we can see the communication in the network, no matter is it the communication from the internal network to the internet, is it the communication between the segments in the network, between the VLANs in the network. We can also see the communication inside the network segment, because we can receive the flow data from the switch in the internal network, so we can also analyze the network communication. So no matter on which part of the attack the attacker is right now, we see some kind of the network communication connected with this attack. So we've got different phases of the attack, and in the next few slides we will see what we can detect on every single stage of the attack. But let's see how the typical network looks like. We've got few main network devices like main router, main firewall, a few switches in the network. We've got the network segments. We've got a few, maybe there are VLANs, or they are separated on the in a different way. We've got many different types of device in the single network segment. So we've got workstations, servers, printer device, or other devices. Using the NetFlow data, we can analyze the communication in a single network segment. So we can detect suspicious communication like network reconnaissance, port scanning, password cracking, exploitation of vulnerabilities, and data collection and data leakage from the network. So we can fill the gap in the network security using our solution. But let's try to analyze how the successive attack looks like. At the beginning, we've got something what is called initial access. On this phase of the attack, the victim receives the email with the link to the suspicious web page, or the attachment with the virus. So in this phase of the attack, we can detect the communication with the host from the reputation list. So we've got a few lists for suspicious web pages, for spammers, for potential attackers, to tell that we see the communication with suspicious IP address. We cannot analyze the payload of this attachment or the payload of the email, but we see that someone receives the packets, receives something from the suspicious IP address. Then we've got a discovery phase of the attack. The attacker is looking for another point to attack. So the attacker is looking for the new victim in the network. How he do it? Just scanning the network. We've got different types of the attacks. So we can make a horizontal scan to scan the whole network. We can make a vertical scan to very, very precise scan a single host in the network, to scan all the services on the host, to detect also vulnerabilities on those hosts. So it's easy to analyze the network hosts and find some new point to the attack. Then we've got credential attacks. So guessing a password to another system. We've got a dictionary attack, we've got a password spraying attack, and few other techniques to detect, to guess the password. So in this phase, we see very specific communication between the attacker and the victim, because guessing a password leaves a very specific footprints in the network traffic. It's easy to detect this kind of activity. Then we've got lateral movements. So having a credential to the one system, we are trying to jump to another one, to infect another system in the network. Then we've got collection phase of the attack. So the attacker collects the data, analyzes the data, and is going to send the data outside the network in the exfiltration phase of the attack. So here we've got the data leakage, but it's not the typical data leakage, because right now the attacker usually use some well-known but not monitored protocols like ICMP or like DNS protocol to send the data outside the network. And on this stage of the attack, the firewall see this this communication. So let's say that firewall was able to see the beginning of the attack, the initial access in the attack on the network, and can see the last stage of the attack, the data leakage from the network. But firewall missed the rest of the attack. So we cannot fully trust into the firewall. Okay, let's try to analyze the attack on the network. I prepared the demo session, the recording of the demo session, to show you how to analyze the communication to detect the suspicious activity in the network. Okay. What we've got here, this is the main panel of the system. The main part of the screen show us the dashboard with widgets to analyze the network situation. We've got pie charts, we've got some KPI charts to analyze the network communication. On the top, we've got the search bar to type the filter, to create the filter, or the search bar to select the time frame data to analyze. On the left part of the screen, we've got menu to switch between the views, between the dashboards, or jump to the configuration part of the system. Okay, what we can do? We are in the security module, so let's go to the dashboards. As you can see, we've got dashboards dedicated for our modules. So we've got a dashboard dedicated for visibility, performance, and security module. And I'm going to use the SOC dashboard to analyze the security situation in my network. In the last 15 minutes, system detected almost 600 alerts, suspicious communication in the network. I can see what was the phase of the attack for every single alert. I can see what was the top client, top server in this suspicious communication. But I would like to analyze a very specific time frame because I received the information that in that time there was some suspicious communication detected in the network. So you can see that we've got almost 3,500 alerts detected by the system, but you also can see that 4 of them were in the initial access phase of the attack. So I would like to analyze this initial access alerts. So I'm going to add this phase of the attack to the filter. As you can see on the top, we've got the filtered data. So let's go to the alerts table to see those 4 alerts. Okay, we see the time of the alert. We see the full name of the alert. So this was the communication with the phishing IP address, but I do not see who was the source and who was the server in this communication. So I'm going to add the columns to my table to add the information about the client and server IP addresses. I've got this, so I can analyze who was the client, who was the server. For me, it looks like the 4th line in the table shows me the communication from the internal network to the internet. So I would like to analyze the communication for this client IP address, because this is mine IP address. It's in my network. Okay, I see only a single alert in the initial phase of the attack for this IP address, but maybe there are more alerts for these IP addresses, but in different phase of the attack. So I decided to remove the initial access phase of the attack from the filter and to see the whole alerts for this client IP address. I see the horizontal scans. I see many different suspicious communication. So let's try to analyze this communication more and more precisely. So I decided to select the time frame to analyze the data very, very precisely. Now I see the alert, but if I will go to the raw data, I will see all the flows recorded by the system. So I see all the flows, I mean all the connections from this host to someone else in the network. So I see that this host scanned the whole network, many different destination IP addresses, many different destination ports to find the open ports and try to attack this host more and more precisely. Okay, let's go back to the alert table for this client IP address. Let's go back to the full time frame of the analysis. This is the horizontal scan detected, but after a few minutes, the brute force attack, the dictionary attack, was detected. So right here, I see the client, the server. I can also add extra column to the table to show which application was attacked by this attacker. I see that. Okay, for the dictionary attack, it was port 22, so it was a dictionary attack on the SSH service, and probably this attack finished with some success, because after that I see the high data transfer between the client and the server. So I see a huge data exchange between those two hosts. But after that, you can also see that the data was sent from this client IP address to the internet. So probably after the downloading the data, the attacker decided to send some part of this data to the internet, to his server, to analyze it much more precisely. And once again, I can add this server IP address to the search bar, go to another dashboard, let's say IP address overview, to see the details about the communication between those two hosts. So I see how much data they exchanged, how much data was sent, how much data was received by those two hosts. I can also analyze the throughput of these connections. So I can very precisely analyze this situation in the network. I can also, once again, jump to the raw data and analyze every single connection between the hosts. I can see the protocol used by the attacker to leak the data from the network. So I can analyze the full path of the attack. But maybe something else also had happened in the network. So after the data leakage, it looks that this victim right now is a part of the crypto mining network, and now this host is used to mine the crypto for the attacker. So we were attacked, we lost the data, and right now our resources are used by the attacker to crypt the cryptocurrency for him. So you can analyze the full path of the attack to see the real situation, the security situation in your network. Okay, let's jump to the another host. Don't want to see it once again. Okay, but one thing is to detect something, and the another thing is to prevent something. So we can monitor our network, then we can detect the suspicious communication, and at the end we can block this communication to protect our network. So how we can do it? From threat detection to network detection and response. Try to imagine that one host in the network is infected by some kind of virus. It means that this host will create some kind of suspicious communication in the network. So our network device will send the flow data to the collector to inform us about the network communication. The collector can store this data, analyze the data, raise the alert, and as the output of this analysis, can run a script to manage the network devices in the network and can enable the rule to isolate the host, let's say move it to the separated VLAN, or block the communication from or to this host, from or to the internet. So it's easy to not only detect the suspicious communication, but also prevent the next steps of the attack and isolate the host from the network and avoid spreading this vulnerability in the network. So we've got a scripting engine to manage the third-part solution to not only detect but also respond to the critical communication in the network. Okay, the short summary about the product. We've got all data in a single place, so it's easy to analyze the data, to collect the data, and it reduces the cost of network observability. We can provide you a pre- and post-sales support to give you a full knowledge about the product and give you a chance to use this product as you want for 100% of usage. You will receive all the value of the product from the first day of using it, after a few hours after the implementation. Of course, if you would like to make some tuning of the system, it's possible and it's easy because the customization in the product is very, very easy. And exactly what we did, you can do it by yourself as well. Thank you very much for your time. Yes,
we have a question from Barbu Butnaru. The threat hunting is done in-house or is imported from well-known security vendors?
Okay, so the analysis is made by our solution. We created a lot of predefined rules to detect unwanted or suspicious communication. So the rules are provided by us, by our security team. Some rules use the reputation lists, and we are using our own list, but we created those lists using many different sources of the data. So we are using the reputation lists from many different places, from many different vendors, but we analyze this blacklist or reputation list to create our own, to avoid the situation with some false positives.
I think that's the point. Any questions, guys? Don't hesitate to ask.